In this video, we are going to talk about compound interest. And so get your notebook ready and title your notes and figure out which notes number we're on, put your date and get that all ready to go. I am assuming that you learned about compound interest in Algebra 2. And so think of this as a review, just a quick review. It's not a thorough lesson. The first couple slides, you don't need to take notes. I'm just kind of developing an idea for you, and then you'll see when it's time to take notes. Okay, so here we go. Suppose you invest $1,000 at 5% annual interest rate compounded annually. This table shows the amount of money you will have at various points of time. Okay, compounded annually means once per year. At the end of the year, you earn your interest. So, suppose you just have invested the $1,000, it's year 0, you have $1,000, that's it. Now, at the end of the first year, so now it's year 1, you have $1,050. How'd we get that? Well, we took the $1,000 investment and we multiplied it by 1.05 because that would be the original money plus an extra 5%. Now you keep your money in the bank or wherever the investment is, and at the end of year 2, you now have $1,102.50. How is that computed? Well, you have your original $1,000 that was multiplied by 1.05 the first year, and that's how we got our $1,050. The money was left in the bank, and again multiplied by another 1.05, the 5% interest made at the end of year 2. We could consolidate this calculation and call it 1,000 times 1.05 to the second. Okay, you leave your money in the bank one more year. Now it's year 3, and now you have $1,157.63. How did we get that? Well, you have your original $1,000. At the end of year 1, we added 5%, so we multiplied by 1.05. End of year 2, added another 5%, and end of year 3, added another 5%. So we keep earning interest on our interest. We could write that as 1,000 times 1.05 to the third. Hopefully you could see how we could generalize this formula if we were doing a 4th year, a 5th year, a 10th year, K years, T years. We would just keep changing that exponent. So earning interest on your interest is what compound interest means. You have earned money, but you leave it in the bank. It earns interest, and then you get just more and more and more. Again, you don't need to take notes on this slide either. Something different happens in this scenario. It says, suppose you invest $1,000, so same investment amount, but this time just for 1 year at 5% annual interest rate, same interest rate. However, this time we're going to compound the money in various ways. Compounding is how many times per year you actually earn interest on your money. So, the table shows the amount of money you will have at the end of the 1 year. All of these values are just the amount of money at the end of 1 year. If you compound your money once per year, we say that that is annually. This is like the previous example. And you have $1,050 because you have $1,000 originally invested multiplied by 1.05. If you compound your money twice a year, that's known as semi-annually. So what happens is you take your $1,000 and you don't get 5% at the end of 6 months and 5% again at the end of 6 months. You get half of that, so 2.5% at the end of 6 months, and then 2.5% again at the end of 6 months. 2.5% as a decimal would be 0.025. Well, let me back up a second. I'm going to write it like this. I'm going to say let's take our 5%, 0.05, and divide it by 2. There's our 0.025. So we multiply by 1.025 twice, once at the end of 6 months and once at the end of another 6 months. So we raise that to the second. Notice that your money was invested for 1 year in both of these situations, but because of the compounding, earning interest on your interest, there's an extra 63 cents by compounding semi-annually instead of annually. 4 times a year is quarterly. So what we would do is take our $1,000 investment, we call that the principal, and then we would multiply it by 1 plus. Now you're going to take your 5% annual interest rate and divide it by 4. And then that will happen 4 times a year at the end of 3 months, 6 months, 9 months, and 12 months. So I'm going to raise that to the 4th. That's $1,050.95. So still only 1 year, still starting with $1,000, still 5% interest, but 95 more cents than the original once per year, and 32 more cents compared to semi-annually. So the more compoundings per year, the higher return you get. 12 times per year would be monthly. Following the pattern then, I would take $1,000 and multiply it by 1 plus 0.05 divided by 12 and raise that to the 12th. $1,051.16. 52 times a year would be weekly, and that would be $1,000 times 1 plus 0.05 to the 52nd, raised to the 52nd because there are 52 compoundings, 1 every week. And then 365 times a year would be daily. So we would have 1,000 times 1 plus 0.05 divided by 365 raised to the 365th. There would be 365 compoundings in a year. Okay, maybe $1.27 is not a huge amount of money, but just for this example of investing $1,000, you can imagine what happens over time if your investments are larger, and also if you have more and more and more years at your disposal, the compounding really does help the money grow. Okay, imagine how we could develop this into a pattern or into some kind of formula. We keep changing the number of compoundings per year. So if we gave that a variable name, we could give a variable name to the interest rate and change that. We could give a variable name to the initial amount of money invested and change that. So that's how we get our compound interest formulas. We have 2 of them. We have non-continuous compounding. That would be a fixed number of compoundings per year, like once a year, twice a year, 4 times a year, 12 times a year. And that formula is A equals P times 1 plus R over N raised to the N. Did you see that? My board went crazy there for a second, so I had to pause and erase things. Let's go again. A equals P times 1 plus R over N raised to the NT. I will explain what all these things are in a moment. And then don't forget about continuous compounding. This is the concept of your money just compounding like infinitely many times a year. And we looked at the number E in one of our videos from last time. It's related to this. So we have A equals P E to the RT. Sometimes we call that the PERT formula. So hopefully you have seen both of these formulas before when you took Algebra 2. A is the final amount of money, sometimes referred to as the future value. So you're taking notes on these formulas, I hope, and jotting down what everything means. P is the principal. That is the initial amount of money, starting amount. R is the interest rate, the annual interest rate, expressed as a decimal. N is the number of compoundings per year. And T is the number of years. So if you need to, pause the video so that you can jot down all of that information and then resume the video, and we have 2 examples to look at. Example 1. Imagine that you invest $2,500 for 3 years at a 7% annual interest rate. Find the future value, the final amount, of the account if the interest is compounded annually, quarterly, daily, or continuously. So for the first three, we're going to use the non-continuous compounding formula, which was A equals P times 1 plus R over N to the NT, where the final amount is what we're looking for. We're looking for A. We know the amount being invested, the principal, is $2,500 times 1 plus. The interest rate is 7%, so we convert that to a decimal, 0.07. And we divide it by the number of compoundings per year. For annually, that it would be 1. And then we raise to the power of the number of compoundings per year times the number of years, 1 times 3. Of course, you don't really have to write in divided by 1 or 1 times 3. And then you put this in your calculator, round your answer to the nearest penny, and we get $3,062.61. Quarterly. Again, looking for the final amount of money, still investing $2,500. We still have an interest rate of 0.07, but we're dividing that by 4 because we're compounding 4 times a year for quarterly. And it's 4 times a year for 3 years, so 4 times 3, 12 compoundings. When you're putting this in your calculator, be sure to put parentheses around the 4 times 3 or just compute it as 12. Do something to make sure that it's accurate. You should expect to get something that is a little bit more than the previous answer because quarterly you're compounding money on top of your money, earning interest on your interest. So you should expect it to be a little bit higher. $3,078.60 if you round to the nearest penny. Daily compounding is 365 times a year. So take your initial amount of money, $2,500, multiply it by 1 plus the interest rate 0.07 divided by 365 and raise to the power of, so 365 compoundings per year for 3 years, 365 times 3. Again, if you're putting that in your calculator, parentheses around the whole thing. And then we get $3,084.13, which is more than the answer to part B because daily compounding, you're earning interest on your interest 365 times a year rather than just 4 times a year or 1 time a year. Continuous compounding, now we're going to use the other formula, which is A equals PE to the RT. E is that Euler's number E, that number that's approximately 2.718 that we talked about in lesson the other day. So plug in the principal, 2,500. E is just the number E, and then raise to the power of your interest rate, 0.07, times your number of years. Now when I'm writing this on paper, I often just put parentheses around both, 0.07 times 3, like that. But when I'm typing it into my calculator, I don't want to type the parentheses like that, or it might not raise E to both of those numbers. So just one set of parentheses around the whole thing ought to make it work, around the whole exponent. Put that in the calculator and you should get $3,084.20. Notice that that is more than the daily compounding amount of money. Not a lot more, but this is basically like the maximum you could get for this particular investment. Okay, one more example. Number 2. Find the amount of money you would need to invest for a future value of $10,000 in 8 years, assuming you earn a 10% annual interest rate, compounded monthly and continuously. So this problem is a little bit different because you're asked to find the amount of money you would need to invest. So we're finding the principal, and we're being told the future value, 10,000, we're being given the final amount, A. For monthly, we're going to use our formula for non-continuous compounding. And we substitute in all the numbers we're given. So we know that 10,000 is the final amount. We don't know the initial amount. We can substitute in the interest rate. It's 10%, so 0.1 is the decimal value. Monthly is 12 times a year. That's our value of n. And we're raising to the, let's see, 12 times a year for 8 years. We're raising to the 12 times 8. Again, I wouldn't type it in the calculator that way. I would just do 12 times 8 in one set of parentheses. Now we are trying to solve for p. All we need to do is isolate p. And we just have p times a number equals 10,000. So all we need to do is divide both sides by this number, as crazy looking as it is, and we'll have p by itself. 10,000 divided by this crazy looking number. 12 times 8 is 96, so I'll just call that 96. We put this in the calculator and we'll know the initial amount, the value to invest, called the principal P. I would be careful not to try to simplify this quantity too much because you don't want to make it approximate. That will throw off your answer if you approximate, and you want your answer to be correct to the nearest penny. When you put this expression in the calculator, you should get, rounded to the nearest penny, $4,508.21. So what that's telling you is if you could invest $4,508.21 at 10% annual interest rate and leave it there for 8 years, compounded monthly, at the end of the 8 years, you would have $10,000. Let's repeat that process for continuously using the PERT formula. And we're going to plug in $10,000 for A. We don't know P. And we have E raised to the interest rate, 0.1 for 10% times the number of years, 8. Same idea. We need to divide both sides by our number over here that's being multiplied by P so that we can get P by itself. So divide by both sides by E to the 0.8. 10,000 divided by E to the 0.8 equals P. And when you put that in your calculator, you should get approximately $4,493.29. Okay, that is our review of compound interest. That's one of 2 videos you're watching today. I know that was a little long. The next video you're going to watch is about log properties. Thanks a lot.